The presented code snippet performs the following functions. Firstly, it attempts to load the RP2 extension, enabling the seamless incorporation of our code into Python notebooks, in case the extension is not present. It initiates the installation of RP2 using pip as a backup plan. If the pip installation fails, the script adapts to install RP2 via the Anaconda environment by executing a system command. Proceeding with the setup, it imports essential libraries including random, seed, choice, cburn, warnings, matplotlib, numpy, and math. To ensure reproducibility, a random seed is established. Future warnings are suppressed, and a function named tossCoin is defined to mimic a coin flip. Moreover, a function called drawDoubleGraph is formulated to display two side-by-side line graphs for comparative analysis. Upon successful loading of libraries and functions, a message confirming the completion of the setup process is displayed. This code guarantees the availability of fundamental libraries and functions vital for subsequent data analysis operations, while also addressing the setup requirements for the RP2 extension if it is not already integrated or accessible within the Python environment. This initialization script is imperative for maintaining a seamless and consistent operating environment for data analysis procedures reliant on these libraries and extensions. The RP2 library is brought in by this code, permitting users to effortlessly interchange between R and Python within a single codebase. This library establishes a seamless interface for transferring objects, data, and functions between Python and R environments, empowering users to capitalize on the unique advantages of each language in the same program. Employing RP2 proves favorable when aiming to access specialized statistical libraries or packages exclusive to R that are absent in Python, or when seeking to merge existing R code into a Python project. By amalgamating R and Python through RP2, individuals can fuse the vast array of libraries and tools accessible in both languages, crafting more potent and adaptable data analysis and visualization workflows. The R script you see here has a dual purpose. Firstly, it incorporates a segment that handles the installation of the gplot2 package in R using the install packages function. gplot2 is a powerful tool utilized for crafting data visualizations and graphs. Secondly, the script establishes a custom function named tossCoin. This function emulates the act of tossing a fair coin. By utilizing runZophone, it generates a random number within the range of 0 and 1. If the produced random number happens to be under 0, 5, the function outputs 1 symbolizing tails, otherwise, it yields 1 symbolizing heads. We are required to apply this script to procure the gplot2 package for designing plots and introduce the tossCoin function to simulate fair coin tosses within the R environment. The algorithm presented conducts a Jackknife resampling analysis to evaluate the bias and variance associated with the mean of a provided dataset. Here's a breakdown of what's happening. 1. First off, datatone and datato were established from dissimilar distributions, normal and exponential, with predefined means and standard deviations. 2. The Jackknife mean function is introduced. It essentially computes the Jackknife mean estimate while also determining the bias and variance. The technique involves iteratively omitting one data point at a time, deriving the statistic of interest on each occasion, and then generating an aggregated estimate using these leave-one-out samples. 3. The Jackknife mean function internally computes the leave-one-out means and pseudo-values based on the provided data. 4. Subsequently, the Jackknife estimation of the mean, bias, and variance is derived by leveraging the leave-one-out means and pseudo-values. 5. To round it off, the test Jackknife function puts the Jackknife analysis into action on a given dataset. It plots a histogram with vertical lines overlaying the Jackknife predicted mean and offers a printout of the estimated mean, bias, and variance from the Jackknife approach. 6. By invoking the test Jackknife function with datatone and datato, distinct plots and results are generated for each dataset individually. The Jackknife technique serves as a valuable tool for estimating bias and variance within statistical analyses, granting insights into the stability of statistical estimators. The code harnesses this method to calculate these metrics for the means of the input datasets datatone and datato. The outcomes are illustrated through histograms, along with summary details to provide a comprehensive understanding. In this script, a simulation study is being conducted to gauge the likelihood that a specific parameter, known as theta, surpasses 0, 2 by utilizing data collected from 3 distinct groups: placebo, gold patch, and new patch. Firstly, random data is generated for each of the three groups mentioned above. Subsequently, the script computes the estimated value for the parameter theta. The next step involves engaging in a bootstrapping technique where the data is repeatedly sampled with replacement. Data is recalculated for each resampled dataset, and the outcomes are recorded. Following that, a histogram showcasing the distribution of theta estimates derived from the bootstrapping process is plotted. Vertical lines are then included in the plot to indicate the point estimate of theta and the benchmark value of 0. 2. The script further proceeds to determine the probability of theta exceeding 0. 2. By tallying the instances where theta estimates from the bootstrapping exercise surpass 0. 2. And dividing this value by the total number of iterations. This script serves as a valuable demonstration of parameter estimation through simulation, a crucial approach when conventional analytical methods are impractical or unreliable. Utilizing bootstrapping enables us to gauge the sampling distribution of a statistic and compute levels of uncertainty associated with our point estimates. Such methodologies are instrumental in a spectrum of domains like statistics, data science, and research, empowering decision-making processes grounded in the available data. The script conducts a permutation test to evaluate the significance of the divergence in means between two datasets, daticon and datao. Initially, it computes the observed mean difference as the initial statistic. Subsequently, it generates reorganized datasets by shuffling the combined data, determining the mean difference for each rearrangement to establish a distribution of reorganized statistics. Through a comparison between the original statistic and the reorganized statistics, the script computes the p-value as the ratio of reorganized statistics that are as extreme as or more extreme than the original statistic. When the p-value falls below the significance threshold alpha, it refutes the null hypothesis, suggesting a disparity in means between daton and datao. Furthermore, the script utilizes a histogram to visualize the distribution of reorganized statistics, highlighting the original statistic with a dashed red line. This graphical representation aids in discerning where the original statistic lies within the array of reorganized statistics. Permutation tests prove beneficial in scenarios where conventional parametric test assumptions are unmet or for dealing with limited sample sizes. They present a nonparametric testing alternative, effectively simulating the null distribution of the test statistic under the presumption of no impact.